Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. On this video guys, we are tackling the second question from the mid-year examination which was written in the year of 2024 in the province of MPUMALANGA. Yes, we are still focusing on mathematics paper 1, and the entire question paper consists of 8 questions, so please do expect 8 videos since each and every question will have its own video. And secondly guys, please do take this seriously, because knowing how to tackle exam questions will give you an edge whenever you write your mid-year exam, your preliminary exam, and most importantly, your final examination. So please do share the video to your peers so that they may have the same edge as you. And lastly, guys, please do help us grow the channel by just subscribing. Okay, we are told to consider the pattern which is given below. We are supposed to determine the expression of the nth term. Firstly, we are not told whether this pattern is arithmetic, geometric, or quadratic. For us to check, guys, let's write down the terms of this number pattern. I simply have 5, -2, and -7. The last term we are given is -10. Firstly, let's check whether our sequence is geometric or not. The sequence will be geometric, guys, if T2 over T1 is equal to T3 all over T2. If this is true, therefore we can conclude that our sequence, or rather our number pattern, is geometric. But over here, guys, you can see that T2 over T1 is not equal to T2 over T3. So this particular sequence is not geometric. Okay, let's try arithmetic. This particular sequence will be arithmetic if and only if the first difference is common. Let's check our first difference. I have -2 minus 5. This will give me -7, and then -7 minus a -2, that's a -5. Already I can see that the first difference is not common, right? And then -10 minus a -7, that's just -3. So since this first difference of mine is not common, I can therefore conclude that this particular pattern is not an arithmetic number pattern. Then the last option I have, guys, is to check whether this number pattern is quadratic or not. And it will be quadratic if and only if the second difference is common. Okay, -5 minus a -7, this will give me a +2. -3 minus a -5, this will also give me a +2. Now I can see that my second difference is the one which is common. Therefore, this particular sequence is quadratic. Are you together? So for me to find the nth term of this sequence, I need to find the values of A, B, and C. Are you together? But how can I do that? I know that 2A is always equal to the to the second difference of my quadratic number pattern, and then 3A plus B is always equal to the first term of the first difference, and then A plus B plus C is always equal to the first term of my sequence. So for me rather to have the nth term of my number pattern, I just need to know the values of A, B, and C. How can I find A? I can simply say 2A is equal to 2, therefore A is equal to 1. Are you together? After finding A, I can therefore go and find the value of B. That's 3A plus B is equal to a -7. I have 3A, that's 3 times 1, plus B is equal to -7. Therefore, B is just equal to a -10. Therefore, let's go and find the value of C. I know that A plus B plus C should be equal to the first term of the sequence. That's 1 plus a -10 plus C, excuse me, that's equal to 5. Therefore, C is basically equal to 5 plus 9. That's just 14. So I now know that the nth term is basically 1 times n squared, which is just n squared minus 10n plus 14. This is our nth term. Okay. our nth term Tn is just n squared minus 10n plus 14. Okay, now you're supposed to show that the sequence will never have a term less than negative 11. Okay, just show that this particular sequence will never have a term which is less than negative 11. Ne? Okay, let's try to solve n. Let's try and check whether we can solve n if if the nth term is less than negative 11. I'll simply have n squared minus 10n plus 14 is less than negative 11. Therefore, n squared minus 10n, then I have 14 plus 11. This will give me a positive 25. And then I have less than 0. I can simply factorize my left-hand side. I'll end up having n minus 5 and n minus 5 again. So this is just n minus 5 all squared is less than 0. This statement, guys, has no solution. This statement has no solution. Why? Because there's no value of n that you will substitute over here and get a negative answer. Why? Because the entire bracket is squared. That means whatever value of n that we get has to be greater than 0. Are you together? So that's why there is no real solution over here. So now I've shown that there's no value or rather there's no term in the sequence that will be less than negative 11. Okay, and then 2.2, I'm supposed to consider this given sequence and I'm just asked to find the sum of the terms of the above sequence. Okay, this type of a sequence, guys, is arithmetic. Are you together? And each and every sequence, guys, will be arithmetic if and only if T2 minus T1 is equal to T3 minus T2. Are you together? If I take 2 over 181 minus 1 over 181, I'll find my common difference to be 1 all over 181. If ever I say 3 over 181 minus 2 over 181, the difference is still 181. 4 over 181 minus 3 over 181, the difference is still 1 over 181. Are you together? So that means this particular sequence of mine is arithmetic. And for me to find the sum of all the terms, I need the values of A, I need the value of N, and the value of D. Are you together? Or maybe I can use the formula that has the last term, because I'm given the value of my last term over there. But it's fine. So for me to find the sum of these terms, I'll just say the value of A is just equal to 1 over 181. The difference is also 1 over 181. The number of terms, I just have 180 terms. If the first term has a numerator of 1 and the last term has a numerator of 180, and the difference in these numerators is just 1, that means the number of terms, I just have 180 terms. Are you together? And then my last term is basically equal to 180 all over 181. So for me to find the sum of the first 180 terms of this particular sequence, I can simply say, let me erase this. I can simply say Sn is equal to A is equal to n over 2 multiplied by 2a plus n minus 1 d. That's 180 all over 2 multiplied by 2 times 1 over 181 plus n minus 1, 180 minus 1, and then the difference is just 1 over 181. Then if I punch my calculator, this should give me my answer. Let me just punch my calculator. 180 divided by 2, open brackets, let me just say multiplied by 2 times 1 divided by 181 plus 180 multiplied by 1 over 181. What does this give me? Let me try to do it without a use of a calculator. I don't trust this answer. That's 2 over 181 plus 179 divided by 181. 180 divided by 2 is 90, and then I have 181. Yeah, that's why I don't trust this answer of mine. My answer is just equal to 90, guys. Ne? I can't even press a calculate. So the answer should be equal to 90. This makes sense. I just added these fractions over there, and then I got 181 over 181, which is basically 1. And then on the outside, I had 180 divided by 2, which will give me 90. So 90 multiplied by 1 is just equal to 90. I could have just found the sum by just using that equation, or simply say Sn is equal to n over 2 a plus l. That's 180 all over 2. The first term is just 181. The last term is 180 all over 181, and then this will just give me 180 divided by 2. This will be 90, and then on the other side I'll simply have 1 plus 180, which is just 181 plus 1 all over 181, né? And then this will just give me 90. You can simply use this one or use that formula, né? But please note that, guys, we only use this one if and only if you know the value of your last term. So the sum of the first 180 terms, is just equal to 90. Excuse me. Okay. And then now we are given the geometric sequence, né? For our geometric sequence, guys, let me erase there and create some room for me to write. In the meantime, I really hope you are subscribing, sharing the video to your peers, and suggesting alternative ways on the comment section. Okay, let's continue. It's 1.21 and 1.331. I have 1.21 and then I simply have 1.331, and then I have 1.4641. 1.4641. So these are the first three terms of my geometric sequence. Firstly, they want us to determine the 12th term of the sequence. We are being asked to not round off our answer. Okay. For us, guys, to find the 12th term, I only need two things first. Né? I need the value of A as well as the value of R. A is basically 1.21, and then R is just 1.331 divided by 1.21. This will simply give me 1.331 divided by 1.21. This will simply give me 1,1. Ne? So therefore, for me to find the 12th term, I must use the general term for my geometric sequence. It simply says AR to the n minus 1. Therefore, T12 is just equal to 1.21 multiplied by 1.1, which is my R, to the power 12 minus 1. So the exponent is 11. So what do we get over there? 1.21 close brackets 1.1 close bracket to the power 11. So this will simply give me 3.452271214. I was told not to round off, so I must write it as it is. Né? So the value of the 12th term, T12 is basically equal to 3.452271214. So that's the value of my 12th term. And then 2.3.2, I'm supposed to calculate the sum of the first 12th term of the sequence, and I must round off my answer into 3 decimal places. I can simply say that the sum Sn is basically equal to A times r to the power n minus 1 all over r minus 1, right? So the value of A is just 1.21, and then the value of r is 1.1 to the power 12 minus 1 all over 1.1 minus 1. So this will simply give me my sum. 1.21 close brackets, open bracket, and another one, 1.1 to the power 12 minus 1 close bracket divided by 1.1 minus 1. So this will simply give me 25 point. I'm supposed to round off into 3 decimal places, right? It's 25.875. This is the sum of the first 12 terms rather of my sequence. So S of 12 is basically 25.875. This is the sum of the first 12 terms. Okay. 2.4. I'm being asked to write the following series in sigma notation. Okay, if guys you are going to look at this series as a fraction like this, it wouldn't make sense to you. Are you together? However, you must look at it as numerators only and denominators only. If you check the numerators, your numerators form an arithmetic sequence, whereas your denominators form a geometric sequence. Are you together? So for me guys to find to express this in sigma notation, this should be I should have Tn over there, which is the general term, and then I'll have n equal to 1, and over there it should be just the position of the last term. Are you together? The position of the last term. So how can I do so? For my numerator, I can see that the numerator is arithmetic. So therefore Tn is basically equal to A plus n minus 1d. The value of A is 1. The common difference 4 minus 1, that's basically equal to 3. So I have 1 plus 3n minus 3. So this is just 3n minus 2. Are you together? So this over there is just the value of my Tn for my numerator. Therefore, let's go to my denominator. The denominator forms a geometric series or a geometric sequence. I know that Tn is basically AR to the n minus 1. So the value of A is 3. The value of R, 9 divided by 3. This will simply give me 3 to the power of n minus 1, right? So therefore, for me to express this entire thing in sigma notation, I can simply say, let me use a different color. Sigma, where n is equal to 1, I simply have 3n minus 2 for my numerator. My denominator is just 3 times 3 to the power n minus 1. Like this, But then I must find the position of my last term over there. What's my last term? I can either use my numerator or my denominator, I think it will be easier for me to determine the last term by using the numerator. Our last term is 22. We just want the position of our last term. That's 3n minus 2. Take the n to the other side. I'll simply have 24 is equal to 3n. Divide both sides by 3. Then n is basically equal to 8. So the position of the last term is 8. Are you together? So this is term number 8 in our series. So I'll simply substitute an 8 over there. So that's how, guys, you're supposed to deal with question 2.4. And then 2.5, we are supposed to consider the geometric series. And then we are being asked that for which values of x will the series converge. The series, guys, only converges if and only if the ratio is between -1 and 1. Are you together? So if r is between -1 and 1, therefore my series will converge. But what is r? R is basically t2 all over t1. In this case, I simply have 4x squared minus 16 all over 2x minus 4. I can simply factorize my numerator over there. This is a difference of two squares, right? The square root of 4x squared is just 2x. The square root of 16, I have 4 and 4. Then I have minus and plus. At the denominator, I still have my 2x minus 4. Please note that these two will just cancel one another, and hence my common ratio will simply be equal to 2x plus 4. Are you together? So since my ratio is equal to this, I must just go and substitute it over there. That means 2x plus 4 is the one which is supposed to be between -1 and 1. But remember that, guys, I'm supposed to isolate x. The first thing I must remove is anything added or subtracted next to x. So the 4 is added. How can I remove an added value? I must just subtract 4. I must just subtract 4, né? But if I subtract 4 over here, that means I must also subtract 4 over there and subtract 4 over there, just to give this statement total balance. So in the middle, I'll be left with 2x is less than -1 minus 4. That's basically -5. And then 1 minus 4, that's -3. I can divide both sides by 2, or rather every term by 2. I'll end up having x, which is in between -5 over 2 and -3 over 2. So for my series to converge, the value of x should be between -5 and it should be in between -5 over 2 and -3 over 2. That's how, guys, you're supposed to deal with this question over there. So I really hope the video helped you out. Please, guys, don't forget to help us grow the channel by just subscribing, and please do share the video to your peers as well. Bye.